Hello. Am I live? I think I'm live, right? Cool. Sorry. So yeah, I'm David Sancho. I work from Barcelona remotely to work for Rabbit. Before I used to work on Typeform. I'm really passionate about design, functional programming, and a few other things aside from running and cycling. So today I want to share what I have been doing for the last 2 months and trying to prove the CSS in Reason on OCaml. So yeah, that's mostly what I want to do today. It's going to be like around 20 minutes. We'll try to make it really fun, I guess. So yeah, let's start. So first of all, if somebody misses the ReasonML kind of the technology, it's a language developed by Facebook. It tends to be a functional, strongly typed language, and that comes from OCaml. ReasonML has a from 2 to 3 years of life, and trends to say that it's a better JavaScript since it compiles to JavaScript. So this is why we do it for using it for the front end. But it's based on OCaml. That means exactly that we share syntaxes and we take advantage of all the compiler from OCaml. And not only the compiler, as well the typing and all of this. So OCaml comes from the meta language family. I think you might be familiar with it. So it's a standard ML, OCaml, and F# from Microsoft. The key things for the language is that it's immutable. So every operation, you return a new data structure. So you don't mutate, you don't go to memory and change the actual value. And you just create a new data structure. That's very convenient when you're working in a huge code base, or you really want to make optimizations and know that what you are doing, it's not gonna do any side effect around your program. That's very, very good. It's very performant. Like, people on OCaml are super obsessed in performance. It's really like crazy how fast it is. Just to give you an example, we have like 1,000 tests, unit tests, and some of them are integration, some of them not, and take less than a second. Sometimes, like the first time that they run it, they were like, "Oh, did that fail?" No, it was like really that fast. That was very impressive for me. It's impure, which is curious, but it's designed to be functional, but allows you a little bit to hijack these functional paradigms to the imperative code. That's super convenient when you come from other languages, because you can do many things on your core of the program that is functional, but then you always gonna do some side effect or some hack that you like cannot express now, or do a binding, and you isolate those. So that's very good. It's the same as many other languages that are half functional programming. One of the other gems of OCaml is inferred typing. So the compiler guesses all the time what type are you working with. So if you got an array, you don't need to specify that it's an array, and the compiler knows that since it's an iterable, it must be an array. So the compiler tells you, or goes to your edit and says, "Hey, this is an array. These are the methods you can run and do it. And if you later change it to a list, which is a different data structure, you're like, yep, the compiler complains," which is very, very, very good. Another aside from the language, like some of the community things, it's battle tested. So that means it's very 20 years old, and it's in maintenance mode. So not in maintenance mode, it's being maintained over these 20 years. It has been mostly used in education and finance. Education, because it's really easy to teach parsers, compilers, ASTs, and some a lot of computer science kind of topics, which education loves it. And on finance, there's like a huge company called Jane Street, which is it for real time. They have like their specific problem, but yeah, there's as well like a company called Ahrefs that they really I think all their stack is in OCaml, so that's good for them. The other thing is the tooling. The compiler is fast, as I said. That their messages are very good, not as good as Elm, as an example, but good enough. They have the same package manager, and I said decent here because there are like one for OCaml and one for Reason. There's a little bit of differences, which right now everybody kind of have their own setup. for this, but I'm really hope that they will join forces and do like a really good package manager at the end. The Reason community has pushed for the NPM Yarn kind of workflow, and OCaml has OPAM and Dune, which is like two combinations of one. But yeah, and the other big gem probably is the portability. So you can compile OCaml to binary code and run it on Windows, Linux. And you can compile it as well to the web, which is why Reason exists. And you might heard about Reason, you know what more or less backup script is the compiler to do that. So cool. That's more or less introduction of what Reason/OCaml is. And a few companies are using Reason ML, not only for the front end, but mostly for the front end. The big ones might be Messenger.com, Ahrefs, as I mentioned, Rapid, where I work. And there's a lot, like as well, Onibeam, which is an editor. So there are many big teams that they bet on the language, which gives you back the promises that Facebook once created. But before like jump into how the CSS in Reason works or how we can do it or whatever, let's do a step back and see how the people from the front end does it. So what's this trend of CSS in JavaScript? I think if you might open Twitter the last 2 years, there have been discussions all around this. I'm not going to get into any big topic, just going to mention how they do it, and we can move forward. So yeah, it allows you to write actual CSS code in your components. So you define CSS, and then you back a component. You can use JavaScript to compose, abstract. So if you are a heavy JavaScript programmer, you would feel very comfortable writing CSS again. And so some big problems of traditional CSS at big scale or at small scale, style collision, specificity. There are many issues with CSS back in the days that with this more or less are solved. There are other solutions that solve that, but this is at least what we're going to talk today. Predictability. So since there are no many problems in CSS, you can have your styles attached to a component and it doesn't break. And are really easy to treat CSS as code, right? And that's one of the points. And it's really well thought for the components architectures, which I think most of us were working with. The two libraries that allows that, or one of the two big ones that allows that, Style Components and Emotion. These two ones, they have an API that looks like that. So you call style.a, that A is the HTML tag, and you put down the CSS, and that link is a component, right? So that link you can render it, and there's a thing here that is a little bit different, but you have props dynamics. So the link.primary is the API of link that makes the bridge between the CSS wall and the JavaScript programmer, right? Like the component that you said. Like this allows us to work with this role that is a designer/programmer, where they design on Sketch or on Storybook their components, and you discuss with them what it should look like, how the API is going to transform, and how can we evolve these components. And I think this is one of the clear benefits for corporations that have design systems or people who's learning CSS or many others. There are many benefits of using style components for sure. One of the things that I don't see them mention it lately or even never is that the predictability of if I'm reading code on the right, so I know that there's a header, right? So there's a header that grabs the logo, there's a drop-down menu, search for user settings, and let's set up, right? So if I'm reading the thing on the right, I really can imagine the UI on the left, right? So I don't need to switch back, right? I can predict that the app contains a sidebar and a main, right? That's exactly what's in the left and the main on the right, right? It's not like, that's not a one-to-one example, but it just showcases how it is to, when you have a component, you go to the render method, in this case, JavaScript. So you go to the render method and you see what it's returning. It's really easy to map to what's in the UI. That's not only thank you to styling components, but thank you to React. But yeah. So the idea is that how can we do that in Reason, right? There has been a talk in React Conf last year that Rafael did about styling your CSS in Reason. I'm gonna leave the talk here because it's 30 minutes long, but they walk through. He walks through all the cases and what the pros and cons, and I think it's a good introduction to how to style CSS in Reason. I'm not gonna get too deep into it, but we can explain more or less the resume of this talk, saying that in Reason everything is styled, right? So you need to specify all the APIs that you're calling needs to have a type, right? You don't need to specify its type, but a CSS turns to be like all property value. You need to know the type. If you do CSS, typed CSS, you would not have runtime errors, and you would get a reasonable API. So you would see here that the display expects a flexbox. Flex direction is a column. So this feels like we are reinventing the APIs of CSS, right? And mostly for the simple properties are fine. Like this is really not reasonable, really easy to understand and to code. But box shadow starts to be very complex. Since CSS it's a language that is super complex, you end up with having weird scenarios, right? Like this syntax is not trivial for a designer, right? So it's very verbose. There's a learning curve since you need to learn all of this. But yeah, and all of the examples is BS Emotion or BS CSS or BS Glamour. The three of them are amazing. Like this is, I would say 50% of the people in Reason are doing styles like that, which it's really good. I think works for them, but I think we could do better. So, and one of the downsides is like the CSS resultant, like the JSX resultant looks like that. So you always rely on class names. That's not ideal for components that contains a hard API. So as we saw before, an API that it's very easy to predict has the properties specified in the component. In this case, we know what's on there, but we need to look about what a card is, what a title is. And that makes it a little bit harder to maintain, I guess. There's another option that is always valid, not even attached to React, but it's a utility first in framework in CSS. The biggest example that came to my mind was Tailwind. We use Tailwind on Drafty. And the component, I think it doesn't fit very well for the component age, right? Like you see how this atomic CSS is very good to wrap up fast a UI, but looks like more like you are typing, like styling a document, right? Felt like hard for me at least to came up to a design system that is running on top of Tailwind, since I was trying to like doing CSS, but I already knew CSS, so I was like, Tailwind was in the middle in that case. I think that many people can benefit from that. It just was a bit hard for me. So I came up with a solution that I have been working for around 2 months, which I try to mimic the styled API into Reason. And I'm using something called PPX that I'm going to explain in a minute. But the idea is that all the models in Reason, all the components in Reason are models. And we can, when I'm getting an example, this is the repo, and that's just like to show. So the idea of a PPX first is a preprocessor extension. It's a syntactic extension that OCaml provides, that you write these little notations and you pass a payload or a value, and then it turns, it runs before the compiler, and then it outputs whatever the PPX is implemented to. So in this case, you get your source code, and the compiler turns to be the AST, like this representation of all your code that the compiler understands. After that, and before typing, before any sort of error message might appear, it runs all the PPXs. So here would be us, and here would be the whatever, like GraphQL PPX, and here another PPX. So first would be us, and then we transform this into here. And this needs to be valid reason or valid OCaml, and then goes to the type tree where the compilation says, oh, this type doesn't match, or the other type doesn't match, and then it compiles. So that's just a briefly idea of what the PPX is, just because like I use it and was needed to explain how my PPX works. So I pass the CSS and I parse it. So I understand every property value of the component definition, and I turn these CSS properties into BS emotion calls. BS emotion is the binding to a motion. So I'm using all the logic that the CSS in JavaScript gives me under the hood. The later thing that I do, I just transform this into React component to turn the AST and then do the loop as I explained. So let me show you how it looks like. So the syntax is very similar. I'm gonna explain a little bit more what this syntax looks like, since like my people come from not experience with reason. So yeah, so models type component is a React component. Usually a style component in React needs to have the thing that I mentioned before, like this tag that is what a PPX, and a make function that is a regular function from reason. In my case, I wrap this in style.div, that which here we define the tag, the same as style components, and then we define the style in a string. In reason, you have these thingies, that is multi-line strings. You could do inline, but it's very common to do multi-line in this case. And then later you use that as a component and you render it in your tree, as you would do it in JavaScript. This difference, like the syntax of it, it's very similar. The benefits of it are a little bit more, I would say. So the purpose of it is to bring the best of two worlds, right? Like you want developer experience to be the best, so you can jump into Chrome, jump into Firefox, and then style something, wrap the CSS, put it back into component, and see it live, right? Thanks to emotion in this case, we can have a hot reload. So meaning that as soon as I change the property, that would update directly the browser. So the developer experience that you could get is as good as playing around with the dev tools. That for me is like the gold star, right? And the other one is maintainability. So since you get errors while you are working with these components, I think it could make life much easier in the backend production, but as well easy to maintain, right? So this is two examples that I came up with. So when these are type errors that the compiler says after my PPX is running, this is all code, all syntax, but it could try to say, hey, you mean yellow, right? Yellow with one L is not on the list of APIs that emotion gives me, so that must be wrong. And the other one is like autocomplete, right? You would see what are the APIs looks like while you are typing. I think these two keys are like an evolution in the sense of a style components, which whatever you put on the component would go to the web. In this case, we can only compile valid CSS, right? So that's cool. A little bit of a warning. So this is still in development. You can use it in production. I'm doing it, but it doesn't fully support all the CSS yet. The API is not it's not going to change. It's just going to support more CSS and on, right? So yeah, that was mostly it. I went a little bit hard onto not giving a lot of context and reason because I wanted to get into a point. I hope that if you know reason and you know that reason plays very well with React, you would get the talk. If not, just come to me. I'm open to talk, to chat about any other topic I mentioned today. And if you feel intimidated about anything, just come to the Discord, and there's like lovely community for it. And yeah, thanks for everything. That was very funny. Hope you like it.